Welcome to Statistical Learning Session. Today we'll be talking about likelihood ratio test. This is a continuation from our last session where we talked about how you can create a constraint likelihood based upon constraint theta. Now let's talk about test statistics. Test statistics for this is likelihood of the maximum likelihood is a difference between the maximum likelihood of theta and minus maximum likelihood of constraint theta, and two terms of that, and that's our test statistics. This is quite related to the Wilks theorem, and this is a Wilks theorem actually, which says that assume S naught is true and Emily technical conditions satisfied, then the test statistics, which we defined in earlier step, is equal to what? What do you think it is? It is equal to, it should be equal to something. Think about it. Since if you go back, this is square of something. It is square of theta. So that's why it should be equal to. So when you say 2 times the difference between likelihood, it must be square of something because of second order of Taylor expansion. And only distribution that is square of something is chi-square. Let's continue let's continue our program. So what I was saying is that this Tn test statistics Tn is the square of something, and the only distribution that has the square of something is a chi-square distribution. So it is chi-square, obviously. Then what's next? Now normally this is chi-square. It is something that is d minus r. It is a chi-square of d minus r. It is a chi-square of d minus r, where d is the total length of the distribution, total number of the is a dimension, and r is the one that is fixed, or r is something that can be that have a freedom of choice. R has a freedom of choice, but d is the total number or length of the dimension, where r are those coordinates which are not fixed. So chi-square d minus r. So it must be equal to that. And once we know this, likelihood ratio test with assumptive label alpha between 0 and 1 is equal to mu, which is equal to test Tn is greater than q alpha, and q alpha is a 1 minus alpha, is a quantile of that of chi square d minus r. And for this to get a critical value of this, we need to look at the table. So that concludes the likelihood ratio test. Let me quickly summarize what we learned today. We learned about the test statistics, and test statistics is defined as a 2 times likelihood of theta minus likelihood of constant theta. And this test statistic is square of something, and only distribution we know of square of something is chi-square distribution, which is a freedom d minus r. And this is called Wilks theorem. So that's all for today. I'll see you next learning session. Thank you so much.